All right, welcome to part one of balancing chemical equations. For the first example we're going to do here, we'll pick a very simple example. Um, let's say that you got a party that we're planning, and we want to show our guests that we think they're extra special. So instead of just buying water from bottled water from the store or serving them filtered water, we are going to make water from scratch, from pure ingredients. So here's the chemical formula for water, and if we wanted to make water from scratch, um, you can see that you're probably going to need a source of hydrogen as well as a source of oxygen. So if you want the product of your chemical reaction to be water, you're going to need some hydrogen and some oxygen. All right. Now, um, notice that, just to kind of reinforce some terminology, in the way I've set it up here, this is a chemical reaction, and it's the it's a chemical equation, and kind of like in math, when you talk about equations, there's like a left side and a right side, and the arrow is kind of analogous to the equal sign in math, and so just like with an equal sign, we need to make sure that the number of things on the left, if you have a certain number of x's on the left, you have to have the same number on the right side of the equal sign, in order to obey the law of equality. Well, in chemistry terms, when you balance a chemical equation, what you're doing fundamentally is you're making sure that you're obeying the law of conservation of matter. So as it pertains to chemical reactions, in order to obey the law of conservation of matter, what that means, and it's really simple actually, is that if you look at each element, you have to have the same number of atoms of each element on the left and the right side of the chemical equation. Okay, so in this particular case, you can see that we have 2 atoms of hydrogen on the reactant side, and 2 atoms on the product side. So that's looking fine. You've got 2 atoms of oxygen on the left side, but only 1 atom on the right side. So that would be a violation of conservation of matter. But luckily, we can use coefficients in the process of balancing the equation to bring that back into compliance with law of conservation of matter. Okay, so I'm going to pick red here for my coefficients. And one thing that I'd like to really highly recommend to you, as you begin, getting really good at balancing chemical equations, is at first keep a little table here, where you tally the number of elements, the number of atoms of each element on the reactant side as well as on the product side. So I'm going to put a little R here for reactant side, and I'll put a P for product side. Okay, so if I look at the reactant side, I see 2 atoms of hydrogen, so I'll put a 2 there. Over on the product side, I've got 2 atoms over there. All right, back to left side, oxygen, 2 atoms. Oxygen on the right, only 1. Okay, so clearly this would be a violation of law of conservation of matter. So we've got to balance it. All right. So the oxygens are the problem at the moment. You've got 2 on the left, 1 on the right. So we can put a 2 here. This is a coefficient. And this is different from the subscripts, right? So the small numbers that are kind of lower and to the right of the elements, these are called subscripts. What we're going to be using to balance this equation is what we call a coefficient, and they're regular sized numbers that come before the compound, before the chemical formula. All right. Then, since we're just starting, I just want to make sure that we understand that the way the coefficient behaves. All right, so when you put a 2 here, or any number, in front of a chemical compound, it's as if it's multiplying through the whole thing. So just like in math, when you have a coefficient and then parentheses, that coefficient multiplies through all the way. So it applies to everything inside. So likewise, the 2 applies to the hydrogen, so that's 2 times 2, so that's a total of 4 hydrogens now. Okay, so I'm going to update our tally. We now have 4 hydrogens, and we have 2 oxygens. All right, so the one, oh, excuse me, I wrote the wrong number. Let me erase that. Now we have 2 oxygens. Okay, now, well, great. We took care of the oxygens. They're now balanced, but in the process, we kind of unbalanced the hydrogens. So we need to increase the number of hydrogens on the reactant side from 2 to 4, and then we'll be balanced. So in order to do that, we put a 2 coefficient here. Now that's 2 times 2 hydrogen atoms, and now everything's in balance. Okay, so we've got 4 hydrogen atoms on the left and the right side, and we have 2 oxygen atoms left and right. That is a balanced chemical equation. And just to be clear, you don't put the parentheses around the compound. I was just using that as just to make an analogy with your math classes. Okay, there we go. That is the balanced chemical equation for hydrogen reacting with oxygen to form water. Great. All right, so you'll have a great party. Your guests will be impressed. Now, let's go to the next example. Let's say we have, so this will be just a little bit more involved. Okay, this is a compound called sodium hydrogen carbonate, and that can react to form sodium carbonate. Sorry about my pen here. I'll get it together. CO2 plus water. Okay, all right. So again, this compound is called sodium hydrogen carbonate, and it can undergo a chemical reaction where it falls apart into these 3 compounds. And now we need to see if we can balance those. So let me use red again. So now we're going to make a little table here. You should, I'd like you to do the same thing there at home if you're doing these. And I highly recommend, by the way, that at this point, by all means, pause the video, see if you can balance this yourself. And then as the video continues, I'm going to work through the solution, and then you'll see what the right answer is. Carbon and oxygen. All right, so this time we've got 4 elements that we've got to juggle. But I think as you'll see, it's really not too bad. All right, so at the moment, so reactant, product, we have 1 sodium on the left, 2 sodiums on the right, 1 hydrogen on the left, and 2 hydrogens on the right. 1 carbon on the left, and 1 carbon here, see that, and 1 carbon coming from the carbon dioxide. So that's a total of 2 carbons on the product side. And then on the left side we have 3 oxygens. Over here we have these 3 plus those 2. So that's 3 plus 2 is 5, plus this one. So that's a total of 6. So 3 and 6. All right. Now, even though this looks like it's fairly involved, we have 3 different compounds on the product side, I think you may be getting the sense from looking at the ratio of the elements left and right that it may be a little easier to balance than you may have been thinking. So if we simply double everything on the reactant side, I think you can see that we're going to bring all the numbers are going to be equal, and that'll give a balanced chemical equation. So let's try, we're going to put a 2 here, 2 coefficient. So now, remember, the coefficient applies to every element in that compound. So we have 2 sodiums, we have 2 hydrogens, now we have 2 carbons, and now we have 2 times 3, which is 6 oxygens. So there you go, 1 coefficient everything falls into place. So that's your balanced chemical reaction. Okay, let's clear the board, move on to the next one. Okay, so for the third reaction, check this out. So we're going to take elemental copper, rather, so copper metal, and we're going to react it with silver nitrate. And when you react those two things, you can form the following: copper 2 nitrate plus silver. Okay, great. Now, let me change my pen to red. Okay, so again, let's make our table. Okay. This is a case where I'd like to share with you a little trick. What's going on with my pen here? Sorry. Okay. Notice, here's a nitrate, and here's a nitrate. One thing that you can simplify the balancing process a lot by keeping them together. Think of them as a unit. All right. So don't try to balance the nitrogens separately from the oxygens. Just when you have a polyatomic that appears on both sides of the reaction, just treat them like a unit. All right. So instead of writing nitrogen and oxygen separately, I'm going to write NO3, a nitrate group. Okay. At the moment, we have one copper on the left and on the right. We have one silver on left and right, but we have one nitrate on the right, one on the left, two on the right. Okay, so the first thing you might want to do is put a 2 here. All right, so that changes the nitrate count to 2. It certainly, you're going to double the silver count, and now you've got your nitrates balanced. But unfortunately, your silvers are now out of whack. But that's corrected easily enough. You just go over here, put a 2 in front of the silver, and now the silvers are in balance. And look at there, everything's fine. So that's a balanced chemical equation for this case. Okay, I think we have time for one more. I'll have to move this along a little bit. Okay, so for the next case, let's take aluminum metal, and when you react that with oxygen gas, you can form aluminum oxide. All right, aluminum oxide. Okay, so again, we'll make our tally. So right now we have one aluminum on the left, 2 on the right, 2 oxygens on the left, 3 on the right. Okay. Well, one thing you could certainly do is, if you start kind of reading left to right, you know that you need to double the number of aluminums on the left in order to get it, equal to what you have on the right. So you can put a 2 there. That's great. But the problem is that doesn't help you with the oxygens, and in order to bring those into balance, you're going to need to use a variation on the crisscross method, which you may remember that technique from balancing the elements within an ionic compound based on their charges. So here you've got two oxygens on the left, 3 on the right. So if you do crisscross, I'll take 3, put that here, take the 2 from here, put that there. And now let's look at what that does to the oxygen counts. We have 3 times 2 oxygens on the left, 2 times 3 on the right, which is 6. So the oxygens are looking great, but now we've doubled the aluminum, so that's 2 times 2, that's 4 on the right. So we're going to need to change this, and let me use my eraser, and that becomes 4. So there's your balanced chemical equation for aluminum and oxygen. Okay, thank you.